In this video, we're going to learn how to implement the binary search algorithm in Python. So the binary search algorithm will allow us to find the index of an element in a sorted list, like this list here. If we don't have a sorted list, if instead we have an unsorted list, we probably have to apply the linear search algorithm. What we need to do is check one index at a time in the list until we find the element we're looking for. So for example, if we're trying to find the element 15 in this unsorted list, we would have to do a lot of checks before we actually find 15. In the case of a sorted list, we can apply the binary search algorithm instead. The binary search algorithm will take advantage of the fact that the list is sorted to greatly cut down on the number of checks required. So for example, if we wanted to find 15 in this sorted list here, instead of checking from this leftmost index onwards, we could actually start checking from the middle of the list, which in this case is going to be this element here. We would see that 15 is greater than this element. That would tell us that 15 must be in this portion of the list, to the right of this element here. If 15 was less than this element, we would know that 15 must be located in this left portion of the list. And that's basically the algorithm in a nutshell, because the next step in the algorithm is basically to apply this same process again to the smaller portion of the list that we've identified. So for example, after the first step of applying the algorithm when trying to find 15, we would have identified that 15 must be in this portion of the list here. We would again find the middle element. In this case, it would be 13. 15 is greater than 13. We would know that 15 must be in this portion of the list here. Again, we would find the middle. This time the middle actually equals 15. We would have found the index of 15 and the algorithm would be done. Let's actually implement this algorithm now in Python. We'll create a recursive function that will call itself at each step of the algorithm with arguments that identify an increasingly smaller portion of the list. So we'll call the function binary search. And the first parameter will be the list itself. The second parameter will be the element we're trying to find. And the third and fourth parameters will identify the portion of the list where the algorithm is being applied, where low is the lowest index where we're still looking for the element, and high is the highest index where we're still looking for the element. And we're going to call the function with different values for low or high at each step to constrain the portion of the list where we're still looking for the element. Now, what could happen is the element could not be in the list at all. If the element is not in the list at all, eventually we'll call the function with a low value that's actually greater than or equal to the high value. If that's the case, that means the element is not in the list at all. And in that case, we're going to return none. Otherwise, we're going to apply the algorithm as we've described it. The first thing we'll do is find the middle index of the current portion of the list that we're looking at. So we'll have mid is equal to low plus high minus low divided by 2. And here we're using what's called integer division or floor division. It's going to give us the result of the division operation rounded down to the nearest integer. And that's to make sure that we don't get a result like 5.5 or something like that for middle. We want it to be an actual whole number that represents the middle index in between the low and high index in our list. And 5.5 would not be a valid index. Next, we'll check to see if the element we're looking for is found at this middle index. So if the element we're looking for is equal to the element at this middle index, then we can just return the middle index because we found the element. Otherwise, if we didn't find the element at the middle index, we'll check to see if the element is greater than the element found at the middle index. If it is, that means the element must be found in the right half of the current portion of the list that we're looking at, if it's in the list at all. So we're going to apply the binary search algorithm to that right half of the current portion of the list that we're looking at. So we'll call the function with list, the element we're looking for, and our new low index is going to be mid plus 1, and our high index is going to be high. So what we're doing here is supplying a new low index, and the new low index is going to be 1 to the right of the current mid index. That's going to give us the element that is 1 over to the right from the current middle index. So the starting point of our binary search algorithm will now be that right half of the current portion of the list that we're looking at. Finally, the last possibility is that the element is less than the element at the current middle index. If that's the case, we're going to apply the binary search algorithm to the left half of the current portion of the list that we're looking at. And it's going to look somewhat similar. We'll have return binary search list element low and then mid minus 1, this time as our new high index. So because we're looking at the left half of the current portion of the list that we're looking at, what we want to do is go from the low index all the way to 1 to the left of the current middle index. That's going to give us that left half of the current portion of the list that we're looking at. So this should be the algorithm. We can save this and try to run the function now. So down here, we'll say result1 is equal to binary search, and we'll call the function with our sorted list, and the element we're going to try to find is going to be 15. And because we're searching the entire list for 15, our initial low index is going to be 0, and our initial high index is going to be the length of the list minus 1. So lists in Python are 0 indexed. That means the index of the last element in our list is going to be the index of the length of the list minus 1. Now we can print out the result. So we'll say print result1. So we'll save this and run our program. And we get 13. And that is correct. So we have the elements from 1 to 16. But we're missing 2. And if you work that out, that means that 15 is at the index 13. Let's try to find an element that doesn't exist, that isn't actually in the list. So we'll say result2 is equal to binary search slist, and I'm going to try to find the element 2, which we know is not in the list. So we'll say 2, 0, and the length of the list minus 1. Let's print out result2. We should get none. So we'll save this, run our program, and we get none for our second result. And so that's how we can implement the binary search algorithm in Python. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.